Hi friends, today we are doing Unit 7, Lesson 11, Gravity, Close Reading Part 1. We're going to start by going over some of the key vocabulary words that you'll be hearing in today's reading. Our first word is gravity, the force or pull created by the mass of objects in the universe toward each other. Our next word is force, a pull or a push on an object or a system. Our next word is matter, the substances all objects on Earth are made of, all substances that take up space. Our next term is gravitational pull, the force that draws all objects in the universe toward each other. Our next term is black hole, an object or area in space that has such strong gravity that not even light can escape from it. Our next word is tides, the periodic or regular rise and fall of the surface of large bodies of water on Earth that are caused by the interaction of the moon's gravity with Earth. We are now going to move into today's reading, which comes from your workbook on activity page 11.1. Gravity. What exactly holds all of this stuff together in this huge universe? Why don't all these stars and planets just go flying off in any direction all over the universe? Why do they stick together in groups and clusters like solar systems and galaxies? These are excellent questions, and the answer is gravity. Gravity is an invisible force of attraction between objects. It's the force that holds galaxies and solar systems together. It's the force that keeps us firmly planted on planet Earth instead of flying off into space. It's the force that keeps Earth orbiting around the sun and keeps the moon orbiting around the Earth. You can't see gravity or touch it, but gravity is present between everything in the universe that has mass. Because of gravity, every single bit of matter in the universe pulls on every other piece of matter in the universe. You and I exert a pull on each other, but because we have very little mass in our bodies compared to celestial bodies, our gravitational pull on each other is very small. So small we can't feel it at all. Gravity depends greatly on mass. So what exactly is mass? Mass is just the amount of matter in an object. You and I are small compared to, say, a planet or a star. We're made of less stuff. So our mass is much, much smaller. Mass is important when you are trying to understand gravity because the larger the mass, the larger the gravitational pull. So objects with really large masses like stars and planets have a really big gravitational pull on other objects. And objects with really small masses like you or me have really small gravitational pulls on other objects. So small we don't even notice the pull at all. The more mass an object has, the more gravity or pull it is capable of. But because Earth has so much mass compared to all of the things that are on the surface of the Earth, its surface gravity keeps the things on Earth from flying off into space. You, your house, your bed, a ball you throw up into the air, all of these things stay on Earth due to gravity. Even the Earth's atmosphere and the oxygen we breathe are held close to Earth by its gravitational pull. Gravity also causes you to have weight when you stand on a scale. Earth's gravity pulls you down. The more mass you have, the harder you pull, and the higher the numbers on the scale. Think about an astronaut who's standing on the moon. The astronaut stays on the surface of the moon because of the moon's gravity. If the astronaut stood on a scale on the moon, the astronaut's weight would be 6 times less than the weight of the same astronaut on a scale on Earth. So a person who weighs 60 pounds on Earth would weigh only 10 pounds on the moon, about the weight of a bag of flour. Because the moon has less mass than Earth, and its force of gravity is not as strong. But the astronaut does not get pulled off the moon and back through space to Earth. Earth still has a larger mass than the moon, and it still has a larger gravitational pull than the moon. But because the astronaut is far away from Earth and very close to the moon, the gravitational pull of the moon has the most effect. It keeps the astronaut on the moon. That's another important thing to know about gravity. The distance between two objects affects the gravitational pull between them. Objects that are close to each other, pull harder than objects that are farther away. The effect of an object's gravitational pull lessens as you get farther away from it. The sun has a lot more mass than Earth does, but the sun is a lot farther away. And because we are on the surface of Earth, Earth's gravity has a much bigger effect on us, keeping us firmly on Earth, one of the many benefits of gravity. The sun contains 99% of all the mass in our solar system. Because the sun has more mass by far than anything else in the solar system, it also has more gravity than anything else in the solar system. The sun's gravity, or force of attraction, is so strong that it constantly pulls the planets toward it. You may be wondering why the planets don't crash into the sun if the sun is pulling them. Don't worry, that never happens because the planets are also moving really fast in their own orbits around the sun. The combination of the planet's own speed and the sun's gravitational pull toward it is what keeps the planets constantly circling in orbit around the sun. It's a perfect balance. The planets continue in their predictable movement around the sun. Sometimes gravity is so powerful that a black hole is formed, an object or area with an extremely strong gravitational pull. There are many black holes in space, and a black hole's gravity is so strong that once something gets close enough, nothing can escape its gravitational pull, not even light. Astronomers find black holes in space by noticing the movements of objects around them. You can't see gravity, but you can observe the way the force of gravity affects objects. Scientists are still learning about black holes, like many other things in outer space. On a clear night, we can often see the moon moving across our night sky. Have you ever been curious about why Earth has a moon? Many scientists think that about 4.5 billion years ago, there was a massive collision between Earth and a very large asteroid. The information they have gathered shows that the moon may have formed from the leftover debris from this amazing impact. Earth's gravity was able to hold the moon in its orbit. There is a strong gravitational pull between Earth and the moon. The moon's gravity pulls on all of the things on the Earth, including people, but the Earth's gravity is strong enough to keep us on Earth. The moon's gravity also pulls on Earth's oceans, but the Earth's gravity pulls back, and it's a good thing it's stronger. The moon's gravity is just strong enough that it can move the water on Earth enough to cause tides in the oceans. Tides cause the regular rise and fall of the ocean's waters. People can see the effects of tides if they are at the seashore. High tides cause the waves to come up high on the beach. And when low tides occurs, the waves don't come up as far. Low tide is a good time to walk the beach and look for shells and creatures that live in the sand. So yes, the powerful effects of gravity can explain a lot of interesting things in the universe. It's what holds our moon in orbit around Earth. It's what causes ocean tides on Earth day after day. Gravity is why we stay on Earth and why objects we throw into the air come back down. Gravity even helps us create new stars and planets by helping pull together the gases and dust that form them. We can't see gravity, but we can see its effects all around us, on Earth, in our solar system, and throughout our galaxy. You may now move on to Unit 7, Lesson 11, Google Form.